All right, 2.1. So simplifying radicals. What a radical is. It is, for instance, the square root of 4. Or the cubed root of 8. Okay, it's the whole entire thing. So it's not just the bottom part, it's not just the root number, okay, but it's that whole entire thing. So for the definition of radical, you can just put the root symbol and everything underneath it. Oh, I spelled everything wrong. There we go. So it is that whole entire thing. Similar word but different, the radicand. This is just everything underneath the symbol. Okay, so for instance, let's just use those same examples that I gave you in the beginning. What would be the radicand of the square root of 4? 4. And what would be the radicand of the cubed root of 8? 8. Okay, so those would just be the examples. Then we have the index. Okay, the index is the number of roots that you have in your symbol. Okay, so the number of roots. So for instance, the square root of 4, what would be the index? 2. And then the cubed root of 8, what would be the index of that? 3. Okay. Real quick off to the side, and make sure you know this. I think you probably already do, but you might just want to write it down. The square, if you have a square root, the index is always going to be what? 2, okay? Square roots are the only one where the index is not written, okay? If you've got a cubed root, there's going to be a 3 written there. If you've got a fourth root, there's going to be a 4, and so on, okay? But square roots are the only ones that do not have that. So you might just want to write that down. If you already know that, you don't have to write it down. Totally up to you. All right, so for the following, it says, identify the radical, the radicand, the index, and then find the real number root. So the first one, square root of 49. What is our radical? It's not a trick question. Yeah, it's just the square root of 49. It's the whole entire thing. That is our radical. What about the radicand? 49. So that's just what's underneath. And the index, 2. Okay, then it says to find the real number root. Okay, so hopefully you did this back in Algebra 1. I'm going to write it off to the side just because I kind of didn't leave myself a lot of room here. But I've got the square root of 49. What I'm going to do is I'm just going to use prime factorization, which means I'm just going to break this number down as far as I can go. What two numbers, any two numbers, what multiplies to give me 49? Yeah, 7 and 7. Are there any two numbers that will multiply to 7? No. Okay, so I've broken that down as far as it will go. And now I want to pay attention. What did I say my index was? 2, right? I've got a little invisible 2 here. Basically, what I want you to think about this as is the index is like the bouncer at the party, okay? He's only letting in groups of 2 of the same number, okay? Is 7 the same number? And it's a group of 2 of the same number, correct? Okay, so how I'm going to write this is this just equals 7. There's nothing else there, so that is my answer. Okay. Letter B, we've got a cubed root of -8. What is the radical? Yep, cubed root of -8. What is the radicand? Yep, just the, what's everything underneath? The -8. You do have to include that negative since it is underneath of that root symbol. Okay, and then we've got our index. What is that? It's 3. Cool. Now, on these negative ones, if the negative is underneath of the symbol, okay, and the power is odd, this is okay. And we'll talk about why that's okay here in a second. Okay, but what I want to do is I just want to go ahead and pull out the -1 first before I break this down. So this is the same thing as just -1, okay, times my cubed root of 8. So I just went ahead and pulled that out. The only time I can pull it out like that is when it's negative, okay? Now I'm going to break down 8. Any two numbers that multiply to 8? 2 and 4. Yep, 4 and 2. 4 breaks down to 2. Okay, so do we see that I have, wait, what is my index on this one? Sorry. 3. Okay, so do we see that I have 3 2s? Yeah, so this is going to simplify down to, that whole thing will just simplify down to 2. Okay, but I'm still multiplying that -1 by it. So what is that? -2. Okay, that one is a little bit tricky. I don't love that I put that one first, but we'll talk about why that is here in a second. Okay, we're going to go ahead and skip letter C, because we'll talk about how to solve that one once we get through our other definition. But let's go ahead and do D, because we can do this one. So it's just a positive 4th root of 81. What's the radical? Yeah, it's the whole thing. What's the radicand? 81. What's the index? 4. Okay, I'm just worried. Let's go ahead and just break it down. That's all I'm really worried about here. I know you know the vocab by now. 81, what can I break that down to? 9 and 9. Well, 9 break down further. 3 and 3. Index, what is it? How many what is the group size that's being let into the party? 4. Okay, so I need 4 of the same number. Do I have that? Yep. And what is the number? 3. So my answer is just 3. Be careful too, just a little side note. If you've broken down a number, so we've already broken down both those 9s, do we all see that? We're done with them. Okay, they don't get to come to the party. We're only dealing with the numbers that we have at the very end. Okay? We'll go on. So here is the important part here. So note, the only time that you can find the real root of a negative number is when the index is odd. It's when the index is odd. And here's the reason why. Okay? So if I have the cubed root of -8, like what we just did, if it's a cubed root, that means I have 3 of the exact same number, okay, that are being multiplied to get me that radicand. Okay? So basically, -2 times -2 times -2 equals what? -8. Okay, so that's why this one works, because there are 3 numbers that multiply to give me that radicand. Okay, but now let's see this example right here. So for instance, the square root of -4. So I need 2 of the exact same number that will multiply to give me -4. Can I do that? 2 of the exact same number, meaning the sign and everything? Because won't 2 times 2, what is that going to give me? A +4, right? And isn't -2 times -2, what's that going to give me? A +4. So there are not 2 of the exact same number that will multiply to give me that radicand, which is why this does not work. Does that make sense? Any other questions or any questions so far on that? Okay. So what do I do with that? So how do I deal with that square root of -4? There is a way. Your calculator will not do it, which is why we've got to do it by hand. And what it is called taking the imaginary number. Anybody heard of that before? Heard of an imaginary number? and we'll call it I. Okay? So what I is, and I want you to write this off to the side either direction, I is the imaginary number. It equals the square root of -1. The square root of -1. So, what I've got here, I want to make sure you agree with me. The square root of -4. Would you agree that this is just the square root of -1 times the square root of 4? Yeah. Because by laws of roots, I can multiply the two things underneath and join them together, right? So that is the same thing. What did we just say the square root of -1 was? I. And then 4, what does that break down to? 2 and 2. What's my index on that? It's not written, but it's just 2, right? So I need 2 of the same number. Do I have it? Yep, and it is 2. So this is just I times 2. To write it more proper, I'm going to write 2I. So don't write I2, write 2I. Yeah, just because it's not written the way that it's supposed to be. You should put the number first, yep. And you'll appreciate that moving forward because it gets sloppy if you don't do that. Okay. Given the following radicals, simplify. So let's try them. So the square root of -49 is basically just the square root of -1 times the square root of 49. We said the square root of -1 is I. And 49 is going to break down to 7 and 7. Can those break down further? No. My index is 2. Do I have 2 of the same number? Yep, and it is 7. So I times 7 gives me 7I. Good. Okay. The next one, square root of -196. What should I pull out? What should I pull out here? Square root of -1, which is just going to be I, right? So I'm just going to go ahead and put I. You don't have to write the square root of -1 because you should know that by now. So just I times square root of 196. Okay, now we're going to break this down. If you don't have a calculator today, I'd go get one. You're definitely going to want it. So now you just need to play around, do guess and check with what numbers can I break 196 into. And we might get several different things, and that's okay because at the end we should get the same answer. But what does 196 break down to? What are just any two numbers? 14 and 14. Okay. Does 14 break down any further? Yes. To what? 7 and 2. So both of these break down to 7 and 2. My group size here, I'm letting in how groups of what to the party? 2. Okay. 2 of the same number. So I've got one group of 7. So I times 7. And I've also got a group of 2s. So I have I times 7 times 2. These values are being multiplied. So I times 7 times 2. What does that give me? Good, 14I. So 7 times 2 is 14. And we still have an I being multiplied. Questions on that? Okay, go ahead and try example 3 on your own. All right, what'd you do first? Square root of -81. What did you do? So I times the square root of 81. Good. What does 81 break down to? 9 and 9. Does that break down further? 3 and 3. So both of those do that. What's my group size? 2, right? So I need to know how many groups of the same number I have. So it's going to end up being I times I've got one group of 3. I've got another group of 3. What does that give me? 9i. 9i. Yes.
Wait, why don't we just stop at 9?
Why? Because the 9s break down further. Okay? Some of these easier examples, okay, because that's a perfect square root besides the negative in there, they will break down really easy, but we're going to get into some harder ones, which is why we use this factor tree. Okay? So you'll definitely want to get in the habit of using this, but good question. Okay. We're going to be doing the same thing now, except for we're throwing in some variables. Okay? I don't know who put letters in math, but here we are. We'll start off with the first one. So this is just square root of 4x to the 6th, right? So the first thing I'm going to do is just break down the number, which we know how to do. What does 4 break down to? 2 and 2. And then we've got x to the 6th. This breaks down to x times x times x times x times x times x. Correct? Because we know when we multiply the exponents, we just add their exponents, right? Or multiply variables, we add their exponents. So that's how that would become x to the 6th. Okay, what's my index here? 2. Okay, it's a square root. My index is 2. So I am circling my groups of 2. So I've got 1, a group of 2. Got a group of x's, another group of x's, and another group of x's. So 2 times x times x times x. So we'll just keep the coefficient. What's that? 2. 2, and then x times x times x. Yep, x cubed. When you multiply exponents, you just add, or when you multiply variables, sorry, you add the exponents. So that just becomes 2x to the cubed, or to the 3rd power. Questions on that? Okay, let's do another one. Okay, normally we start with the numbers first, but this one doesn't have any numbers. So a cubed is just going to be what? A times a times a. B to the 6th is going to be? You got it, 6 b's. What is my group size on this one, or my index? 3. Okay, this is a cubed root, so this is groups of 3 of the same thing. So I've got one group of A's, right? How many groups of B's do I have? 2. So times B, or just times B squared, right? So this becomes AB squared. With me so far? This isn't too bad. Okay, looking at example 3 now. The first thing I notice, what's the first thing you notice? It's a negative, okay, but just look, is this negative okay? Is this one going to be imaginary? How do I tell? So, yeah, there's a negative 27 underneath, but how do I tell if it's an okay negative or if I need to make it imaginary? What did we say? What do we have to look at?
Okay.
The index, right? And the index is 3. Is that even or odd? Odd. So that means that this is okay or not okay? It's okay. Okay, you can have an odd index and have a negative under there. Okay, think back to our cubed root of 8. Okay, we had the 3 negative 2's. That was okay. Okay, so for this one, I'm just going to go ahead and pull out that negative. Because I know if I have that underneath that my answer is going to be negative. Okay, so I'm going to pull that out. And now I'm just going to break down the 27. What does 27 break down to? 9 and 3. Do any of those break down?
Yeah.
3 and 3. How many people in my party? 3. And I have that, right? 3 of the same number. So this just becomes a times 3. So we got negative 1 times 3. Am I done yet? Yep, I still got to take care of this c to the 6th. How many of them do I have? 6. And how many groups of 3 is that? 2. So times c times c. So what is negative 1 times 3 times c times c? Yep, negative 3c squared. Negative 3c squared. Anybody confused on how we got that answer? Okay, because again, you just multiply coefficients and then add your exponents. Cool, let's go ahead and move on. Example 4. Looking at that negative, is that okay? No, why not? Because the index is positive, so what do I need to make that negative into? And what do I do with it? Go back to the other examples. How did I pull that negative out?
Do 1x, right?
I, right? So if it is an even power, that negative just becomes an I. So now I just have I times the rest of it, okay? So 16 is going to break down into 4 and 4, that works. You could have done 8 and 2 as well. The 4's then break down to 2, 2, 2, and 2. I'm letting in how many people to my party? 4. How many groups do I got? Just one group of 2, right? So 2 is what that becomes. How many Q's do I have? 12. So how many groups of 4 will that be? 3. So a little shortcut on that. You can just take your exponent inside and divide that by your index. So you can take the exponent and divide that by your index. You might want to write that down. So divide the exponent by the index. So the inside exponent by the index. That's going to give you your group sizes. Okay? So that's a little secret because, hint, hint, on the next one, it would be really treacherous to write out 22 R's, right? Nobody wants to do that. So if we just divide our exponent by our index, it gives us what we need. Okay, simplify this. I times 2 times Q3.
2IQ3.
Perfect. 2IQ3. Good job. 2IQ3. All right. Questions on that one? All right, go ahead and try number 5. All right, so you should have got 4R to the 11th. 2 groups of 2 and 11 groups of R. Okay, looking at number 6. Negative square root of 81c squared. So be careful on this one. I do have an even root number, okay? Does that mean that that negative is going to become an I? I see some heads shaking. Why not? It's outside, right? So we just leave it alone, okay? We don't have to make that imaginary if it's outside. Basically, that's just a -1 times square root of 81c squared, okay? So we'll just go ahead and we'll just go ahead and write the -1 out here just so we know it's being multiplied by our answer. 81, what could we break that down to? 9 and 9. 9 breaks down to 3, 3. Okay. Group sizes? 2. So I've got what? 3 times 3. 2 groups of 3. And then we got c squared. How many groups is that? Just one group of c. So we just got c by itself. So -1 times 3 times 3 times c. -9c. Good. Questions on that one? Okay. Next up. This is where we understand why the factor tree makes sense. So sometimes you're going to have some non-perfect radical expressions, meaning not everything gets to come to the party. Okay? So if a value can't be split off perfectly, we have to factor tree it, just as we've been doing. The index is going to tell you still your group size, okay? So the index, scratch out that how many, and put group size here. Index is going to tell you the group size. If, that's a typo, if something isn't in the group, then it's going to stay inside the radical. Okay, so the radical is home base, right? If it's not going to the party, it is staying home. It's staying inside. You're not doing anything with it. So we'll go ahead and try square root of 500. Let's break it down. A couple ways we could go with this. 2 numbers that multiply to 500. What'd you say? 5 and 100, that works. Can 5 break down? No. What can 100 break down to? 10 and 10. Will 10 break down further? 5 and 2. Both times. Okay. My group size on this one, or my index, is 2. Okay, so it looks like I've got one group of 5. I've got one group of 2. And then is there anything left? Yeah, there's still a 5 out here, okay? It doesn't have any friends. It doesn't have a partner. So it's not going to the party, okay? Because they're only letting in groups of 2. He doesn't have anybody. So we are going to leave him under the square root symbol. Just leave him alone. He's not going. So now we simplify this. So again, we're always multiplying these variables. So 5 times 2, not 5 plus 2, 5 times 2 is what? 10. And then we can't multiply anything else. We'll just leave that square root of 5 on its own. But that is our answer. 10 square roots of 5. That's how you would read that. All right, moving on to example 2. We've got square root of a to the 3rd. How many a's do I have? 3. So this just becomes a times a times a. What is my group size? 2. So I've just got one group of a. What's left over? The extra a. So we're leaving it under the square root. And the more proper way to write this is just to get rid of that multiplication symbol. We just write them next to each other. So a square root of a. A square root of a. Questions on that one? Okay. Go ahead and try this one. Try example 3. All right, how'd you break down the 24? 12 and 2, that works. Could have done 8 and 3, could have done 6 and 4. Doesn't matter, you should still get the same answer in the end. 12 breaks down to, and 6 breaks down to, cool. Group sizes.
One group of two. Oh,
Yep, so
sorry.
the group size is 3, yeah, so one group of 2 here.
And then you leave that 3.
Yep, I'm gonna leave the 3 underneath of the cubed root symbol. What about the A's? How many groups of A's do we have?
2 groups of 8 and 1 A.
Yep, so like we said, we can divide that exponent by the index. So 7 divided by 3, that gives us 2 whole groups. So A times A, or A squared. And then we have a remainder of just 1, right? Because there were 7 A's, 2 groups of 3, and then 1 left over. Okay? This just simplifies down to 2A squared cubed root of 3A. Raise your hand if you got that one. Some of us, good deal. If you didn't get that one, make sure you realize what you did. Questions on that one? Okay. Example 4. So, how this one reads is we've got 4x times cubed root of 24x to the 7th. Okay, is that 4x underneath of my radical symbol? Or my is it a radicand or no? Is it inside of anything? No, it's just being multiplied by my answer. So I'm just gonna go ahead and write it out. Now I've got to simplify this guy, okay? Break down 24. I need 2 numbers. What do we got? 4 and 6. 4 breaks down to 2 and 2, 6, 3 and 2. I'm looking for groups of 3. Do I have one?
Yeah.
Yep, a 2. Anything left over? A 3, so that's gonna go inside my root, right? I'm just gonna write it back behind just because I know I still have variables to deal with. That's why I'm doing that. I know it's still being multiplied. That x to the 7th, what's that do?
2 groups and then 1 left over.
Yep, 2 groups and 1 left over. That actually ended up being just like that other one. So if you aren't great at division and you want to write it out, 2 groups of x, 1 left over. Okay, well, let's simplify this guy right here, because that's not as simple as we can go. What can I do?
Would it be 8x to the 3rd? Or
Perfect. 8x to the 3rd. So you multiply the coefficients out here. 4 times 2 is 8. X to the 1st times x squared is x cubed. Leave the radical alone. Don't multiply that 3x by anything on the outside, okay? Because they're not going together. So that is my answer. Any questions on that? Feeling good about this? Do we feel like we could do number 5?
Yeah.
Yeah? All right. Try it out. Do 5 and try 6 for me too. Okay. Number 5. First things first. I'm going to write after that equal sign. Do I have something outside already? Yeah, what is it?
3x squared.
Yeah, so I'm going to write that over here because I know I've got to deal with it later. Okay? So that's the first part of my answer, or what I'm going to make into my answer. Now I've got to deal with this 4th root of 80y to the 14th. So I saw a lot of us got this far. So we break down the 80. What do you want to break it down to? Doesn't matter.
8 and 10.
8 and 10, that was a popular one I saw. Okay. 8 breaks down to
2 and
2 and 4, and 10 breaks down to
5 and
What'd you say? 5 and 2. Four breaks down to 2 and 2. Okay, make sure you break everything down all the way. All right, what are my group sizes here? 4, okay, because that's my index. My index is 4. Do I have any groups of 4? The 2s, right? Got 4 of them. So that just becomes times 2. Okay? Is there anything left? Just the 5, right? The 4 we already broke down. Okay, I saw a lot of us tried to take that 4 over there, but we already broke that down, so we don't gotta worry about it. Okay? So now I've got this 5, and what do I need to do with it? Put it under what? Yeah, the 4 root, okay? Keep your same index. Don't change it to a square root, okay? I saw a couple of us did that. So make sure that you do that. The reason I'm writing it on the end is just because I know I write that at the end of my answer, okay? You could write it right next to it. It's fine. Just make sure that you don't put the y's underneath of there that aren't supposed to go there, okay? So I'm just going to go ahead and put my 5 here. I've got how many y's? 14. Okay, I could go ahead and write out y times y times y 14 times, or I could just know that 14 divided by what? Divided by my index. How many times does 4 go into 14? 3 times, and a remainder of 2. Because 3 times 4 is 12, and then 2 more would get you to 14. Okay, so since I have 3 of these y's, 3 groups of y, this is y to the 3rd. How many did we say were left over?
2.
So that's going to go where? In the group thing. In the root thing. Okay, if this whole division thing confuses you, just write it out. Write out y 14 times. I don't care. Okay, just as long as you get the right answer and you know that one group of 4 is just going to be y. So another group would be times y, another group would be times y. So that's how I got y to the 3rd. Now, I'm going to take my answer and write it in its simplest form. How can I simplify this 3x squared or times 2y to the 3rd?
6x squared y to the 3rd. 8.
Yep, and then keep my root. Just like that. Don't combine your x's and y's. They're not the same variable. Okay, 64, how'd you break that down? Or how would we break that down if you didn't get that far? Any two numbers that go into 64?
8 and something.
8 and something. What's 8 and 8? Will 8 break down?
Yeah.
To what?
4.
Ooh, 4 times 4?
4, sorry.
Yep, be careful. Use a calculator if you need to. 2 times 4. Any of those break down further?
4.
4 breaks down. Okay. Group size on this one?
4.
4. So I've got 1, 2, 3, 4. So that's one group of 2. So 2 times is going to be what I put out there. I'm done with those 4 2's. What do I have left?
2. Those 2 2's.
2 of my 2's, right? Can that make a group?
No.
No. So what I need to do is put that into my root symbol. 2 times 2. There's still 2 of them left. 2 times 2. Okay. The x's, I got 3 of them. Is that enough to make a group of 4? X times x times x. Can that make a group of 4? Nope, so I'm leaving that underneath as well. Can't do anything with that. What about the y's? What was that? One group, right? Because I got 7 of them. So I got groups of 4. That gives me 1 group. So it's out here. How many are left? 3. So that becomes y to the 3rd, and that's underneath the radical. All right. Let's simplify this. So 2 times y times my radical. So what's 2 times y? 2y. This radical actually can simplify underneath. We haven't had one like this yet. But it's 2 times 2 times x cubed y cubed.
4x cubed y.
Yep, 4x cubed y cubed. Good. And that is the final answer. Questions on that one? It's a little bit trickier than what we've seen so far, but we can do it, right? Okay. Last one we got. Go ahead and give this one a shot, and then we'll go over it in about a minute. All right, last one. First thing you wrote down was what? Yep, so put that 5 in the answer. 5 times. Now we're going to break this down. What'd you break it down to? What'd you say, 10 and 6? Okay. What'd 10 break down to? 5 and 2. 6. 3 and 2. Group size? 2. Do I have any groups of 2? What are they? Just one group of 2, right? One group of 2. So far we got 5 times 2. What's left over? What do we not deal with yet? 5 and 3. Are those the same number? No, so they cannot be a group. So we leave them where? Yep, underneath the radical. So it's just 5 times 3. Don't put 53, okay? It's not the number 53. It's just those 2 values being multiplied. My u's, how many groups of u do I have? So I have 3. How many groups of 2 is that? 1. How many is left over? 1. My v's, how many groups of 2 do I have there?
2.
Yep, 2 groups. 5 divided by 2 gives me 2 whole groups. With how many left over? 1, so it stays underneath. How many people got that far? Good. Hopefully if we didn't, we know what we did wrong. Let's simplify it. Let's just work with the outside first. What does the outside become?
10 UV squared.
Perfect, 10 UV squared. 5 times 2 is 10. And now the radical.
15 UV.
15 UV. Is that it? Yep. That is all. Questions today? Anything not lining up? All right, that's a wrap. Make sure that you get on Delta Math first and do that. And then your homework is after that.